ever stopped to wonder how we can be so certain about scientific laws? I mean, really, how do we know that gravity is going to work the same way tomorrow as it did today? Well, in this explainer, we're diving back into the 18th century, a time when that exact question was causing a huge crisis in philosophy. And we're going to look at how one man, Immanuel Kant, came up with a truly revolutionary answer.
Okay, so to really get what Kant did, we first have to understand the mess he was trying to clean up. In the 1700s, science was having a moment. It was unbelievably successful. But philosophy, the very field that's supposed to explain how science works, it was completely stuck at a total standstill.
And this was the big one. This was the question at the absolute heart of the crisis. See, science makes these huge claims about universal, necessary truths, laws that apply everywhere, always, no exceptions. But where does that rock-solid certainty actually come from? Philosophers were completely divided on this. So you had this intellectual tug-of-war going on. In one corner, you had the rationalists, guys like Leibniz, who believed that all true knowledge comes from pure reason, just by thinking things through. And in the other corner, you had the empiricists, like David Hume, firing back that, no, all knowledge has to come from what we see, hear, and touch, our sensory experience. This was a massive problem for science, right? Because reason alone can't tell you how the physical world works, but your personal experience is always limited. You can't be everywhere at once to prove a law is truly universal. And Isaac Newton's work was the elephant in the room. His laws of motion and gravity worked with just breathtaking precision. They could predict the movements of the planets. It was incredible. And yet no philosopher could really explain how we could be so sure these laws were absolutely universally true. So you had this bizarre situation where science was working perfectly in practice, but was a total mess in theory. So into this philosophical gridlock walks Immanuel Kant. And he doesn't just pick a side. Oh no, he proposes a solution so radical, so game-changing, that he himself compared it to the Copernican revolution. You know, the one that taught us the Earth revolves around the sun, not the other way around.
And this is where Kant completely flips the script. For literally centuries, the assumption was that our minds are passive, kind of like a camera just trying to capture an accurate picture of the outside world. Kant says, nope, we've got it backwards. He argued that our minds actively structure the reality we experience. Objects, as we perceive them, are forced to fit into the framework that our mind brings to the table from the very beginning.
A good way to think about it today is like this. The mind isn't a blank hard drive waiting for experience to install programs on it. It's more like a computer that comes with a pre-installed operating system. All the raw data that floods in from our senses gets organized and structured by this fundamental software before we even become aware of it. So what's in this preloaded software? Well, Kant identified these key structures he called a priori concepts, which just means they exist before any experience. Think about it. You don't learn that time exists by experiencing things. You experience everything within time from the moment you're conscious. Same for space. He argued that causality, the idea that every effect has a cause, is another one of these built-in rules. These aren't things we discover in the world. They're the very rules our mind uses to make sense of the world in the first place. Now, this Copernican revolution wasn't just some abstract philosophical game for Kant. He used this powerful idea to build a very strict blueprint, a set of rules to figure out what could actually be considered a proper science and what couldn't. He lays this all out in a super important book called The Metaphysical Foundations of Natural Science. This is where he gets down to the nitty-gritty, moving from his big theory about knowledge to a practical guide for what makes a field of study worthy of the name science. So what's in this recipe for a proper science? Kant lays out 4-point checklists. Number 1, it has to be systematically ordered into a coherent system. 2, it's got to be based on rational principles, not just a scrapbook of observations. 3, its most basic laws must have what he calls a priori certainty. They have to be necessary truths. And finally, the big one, it has to be mathematical. Here it is, straight from the man himself. For Kant, this was the ultimate litmus test. The ability to express the laws of a science in the language of mathematics was non-negotiable. Why? Because math is pure, it's structured, and it gives science the absolute certainty that experience alone never could.
Now, as you can imagine, this line of thinking led Kant to create a pretty clear hierarchy of the sciences. His criteria created a very exclusive club. So when he applied his blueprint to the sciences of his day, well, let's just say not everyone got an invitation to the party.
At the very top of the list, no surprise, was physics. It had these universal mathematical laws, like Newton's, that seemed to be perfectly grounded in these a priori principles. But then you get to the B list. And for Kant, that included fields like chemistry and psychology. In his view, they just failed the test.
So why did chemistry get the boot? Well, Kant argued that at the time its principles were, in his words, merely empirical. It was basically just a well-organized collection of experimental results. He called it a systematic art, kind of like a cookbook, with recipes that work, but no one could derive those recipes from pure reason and mathematical proof.
And psychology, it was in even worse shape, according to Kant. And his reasoning is actually pretty fascinating. He argued that all of our internal thoughts and feelings, our inner world, they only happen in time. And time only has one dimension. It moves forward. He believed you couldn't really apply mathematics to that single dimension in a meaningful way, unlike physics, which can map objects across 3 dimensions of space.
So after he sets up this strict hierarchy and lays out all these rules, what's the big takeaway from Kant's whole project? I mean, why are we still talking about this guy more than 200 years later?
Because ultimately, Kant offered this masterful solution to that crisis we started with. He didn't pick a side between reason and experience. He showed how they work together. He built a bridge between the two camps, and in doing so, he grounded the incredible certainty of science, not in some mysterious external world, but in the universal, unchanging structure of the very mind that perceives it.
And that leaves us with a really provocative question for our time. Kant's entire system is profoundly human-centric. It's all about the structure of our minds. But today, in an age of big data and AI that can spot patterns no human ever could, does science still need that human-centric foundation? Or are we maybe stepping into a new era of knowledge that Kant himself could never have even imagined? Something to chew on. Thanks for watching.